Hello and good morning, geometry students. What we're going to be covering today is geometry, Unit 3 activity. So we're going to mostly be talking about congruent triangles, and then we'll later get into some geometric constructions. If you need any help after watching this video, then please email me. Email is trig@ofy.org. So that's TTRIGG@OFY.org. All right, with that being said, please watch the video and we'll hopefully get through this. This is going to be kind of a long one, so if you need to pause at any point, you're welcome to do that. You can pause, rewind, take a break. So let's get started. When we learned about congruent triangles, there are 3 criteria that we know for sure that we've already learned. So the first one was SSS, meaning that if 3 sides from one triangle match 3 sides from another triangle, then that forces these 2 triangles to be congruent. So in other words, we know all the sides are congruent. You can see that from the 3 sides here. But that would also force the angles to be congruent as well. Similarly, there's side angle side similarity, SAS. So if you have a side, then an angle, then another side congruent, side angle side, notice the side angle and side are the same on each of these. Then that forces the 2 triangles to be congruent. So the other unknown side would also be congruent, and also the unknown angles have to be congruent to each other as well. Congruent again means they have the exact same size, exact same shape. So these triangles are congruent. Also, angle, side, angle. So these are the 3 that we learned. Angle, side, angle. You have an angle, then a side, then an angle, then side, then angle that are congruent, meaning that that'll force the 2 triangles to be congruent. Now, the 3 things we're going to try today is we want to try these 3 criteria. We don't know. We don't know about these 3. Side, side, angle, 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 and side, angle, angle. We don't know if those are enough to prove that the triangles are congruent. See, these ones we know. These ones we know that if it follows this criteria, then the triangles must be congruent. But these ones we don't know. I'll give you a hint. Maybe some of these will work, maybe some of these won't. Okay, so let's take a look at the activity. Part A. Please read along as I read aloud. Determine whether side-side angle, SSA, is a valid means for establishing triangle congruence. In this case, you know the measure of 2 adjacent sides and the angle opposite to one of them. If it is a valid criterion, explain why. If it is not valid, use GeoGebra to create a counterexample demonstrating that it doesn't work and give an explanation. Excuse me. Hint, try constructing a triangle where the known angle is opposite to the shortest known side. If you construct a counterexample, take a screenshot of your work, save it, and insert the image in the space below. Okay, so you can click on this link right here, GeoGebra, and it'll pull up the GeoGebra app. Okay, very good. Looks like this. Okay, so the first thing kind of the hint told us was to construct a triangle. So we're going to go to this polygon tool. And I'm going to construct a triangle. I don't really want these grid lines all over the place. You can click these right here. And let's see. How do I get rid of this? Oh, you can click right here, and you can click on these grid lines, gets rid of those. Click on this, gets rid of the grid, and you can do it like that if you want. It doesn't really make a difference. For me, it just makes it cleaner. Okay, so we're going to go to the polygon tool, polygon, and we're going to make a polygon. We're going to make a triangle. So triangle A, B, C here. Okay, So you have to make the triangle, click, click, and then click back to where you started. And now we have our triangle, triangle ABC. Okay. So we want to know some measurements here. So remember, we're checking side, side angles. So we need side, side, and angle. What we're going to do now is go to some measurements. So we want to know some measurements. We want to know two measurements of sides and the measurement of an angle, since it's side, side, angle. So first, let's look at the sides. So go to distance and length. It's under this toolbar here, distance and length. Go ahead and click on this side and this side. So that gives us the lengths of these two sides. I like to kind of have it outside the triangle, but it doesn't really make a difference. All right, and now I want to also measure the angle A here. So go to that same tool up here and go to angle. So click angle. Click this side, then this side. It'll give you the measure of that angle, just like that. Again, I like to have the measurement kind of outside here. All right. Now what we want to do is go to this circle tool. We're going to go to circle with center through point. Okay, so go and click that one. We want the center of the circle to be at B. Let's go ahead and click B first. And we want the end of the circle to be at C, just like that. Okay. Now, I might have messed up my triangle a little bit. What I would want is actually, I want to move this one so it's kind of outside the circle like that. Okay. So if your angle A is inside the circle, go ahead and move it to where it's outside the circle. That's going to change some of these measurements. That's okay. Next, we want to do is we want to create a line segment. So on the toolbar, the third one from the left here, you can go to segment. So don't do the line, do the segment. So click segment. And one of the points of the segment is going to be this intersection right here, this intersection of AC and the circle. Click that intersection and then click on B. So we've created, you can kind of see there's actually 3 triangles now in the picture. There's this one right here. There's this one over here. And then there's the big one that kind of encompasses both. Now I want to know the length of BD here as well. So again, on the toolbar, go to this one here, go to distance and length, and we're going to click on BD and it'll give us that length. Okay, so now let's look at, we actually have 2 triangles that have the same angle. So notice this small triangle, ABD. Notice it has this angle 26.08, and it has these 2 side lengths. Side, side, angle. Side, side, angle. Well, look at the big triangle, the biggest one. It has that same side, and this same length as this, side, side, and the same angle. But is this small triangle congruent to this big one? No, clearly not. These are clearly 2 different triangles. So in other words, we produced 2 different triangles, they're not congruent, that have the same sides here and that same angle. So since we're able to do that, we've produced 2 triangles with the same side, side angle, but those 2 triangles are not congruent, which tells us that side, side angle is not a way to prove that triangles are congruent. Okay, so I want to go get the snipping tool. So the snipping tool, so I can take a screenshot here. So I go to new, I'm going to take a snip of this. So this is our counterexample because we produced 2 triangles with side, side angle, but they're not congruent. Okay, so go ahead and copy that. Go onto our activity, and then I'm going to paste that. Okay. Well, you may have to I'm having a little trouble copying pasting. Hopefully you don't have trouble copying pasting. But if you do, then you can, let's see, I could try to save this image. File, save as. Well, if you have trouble copying pasting, just let me know and I'll help you out. Okay. So the explanation, we get at least to the explanation. We produced two non-congruent triangles that have congruent side. Therefore, SSA is not a valid means for establishing triangle congruence. I still don't know why it's not copying and pasting. Oh well, don't worry about it. All right. So next one, part B, is angle, angle, angle. Okay. Oh, by the way, for yours, I need to have that image in there. Okay, so if you don't have that image, I really need that image in here in order for you to get credit. Okay, so if you have trouble copying, pasting, that's okay. So you could save the image and then put it on there later. Okay, so next, determine whether angle, angle, angle is a valid means for establishing congruence. Okay, so again, we're going to go to GeoGebra. We can delete everything here, so you can go to this and just do new. We don't need this one here. Make sure you've already saved the image, but I don't necessarily need it, so that's okay. But you might need it. If you need it, save it. Okay. So first, let's produce a triangle. In this case, it doesn't really matter what the triangle looks like. Just any old triangle will do. I'm doing this triangle right here. Okay, cool. Now, what we want to do is we're going to make the same triangle, but we're going to dilate it. Okay. Also, since we're dealing with angle, angle, angle in this example, we're going to need the measures of all the angles. So go ahead and go to this angle here. If you click here and here, it'll give you that measure. Here and here will give you this measure. Here and here will give you this measure. So now we have all three angle measures here for the three angles for this triangle. Okay. Now, again, we're going to go to the dilation. So go to this tool right here. It looks like a red and a blue dot separated by a line. Click on that. And we want to go from dilate from point. So that. We're going to click on the triangle, and then you can click pretty much anywhere. And we want to change the size. So you could use any factor you want. Don't make it too big though. If you just want to make it a little bit bigger, that's good. So I'll do 1.5. So it'll be 50% bigger than the other one that we had before. Okay. So now, as you can see, we have our other triangle here, the dilated one. So it's bigger than the one we had before. Notice they're kind of on top of each other. I don't really like that. So what I might do is move D so that they kind of separate a little bit. Okay. Yeah, that looks good. Maybe I'll move it a little more. There we go. Separate the triangles. Okay, so now you might notice that these triangles look pretty close to each other, except just the newer one is bigger. Yours might be smaller depending on what your dilation factor would be. But okay, let's go ahead and, like we did with this one, find the angle measures. So go to the angle measuring tool, which is right here, angle. Click here, 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 here. Now, as you can see, the 3 angles from my new triangle match the 3 angles from the other triangle. All the angles are congruent to one another. Now, since all the angles are congruent, we could say that they are angle, angle, angle. But are the triangles congruent or just the angles? Well, these triangles are clearly not congruent because they are not the same size. So, in this case, we have 2 triangles that have all their angles matching. However, the triangles are not congruent themselves. So, we can say that angle, angle, angle is not a valid means for triangle congruence. Okay. Let me see if I can copy and paste this one. C, Control V. No, it's not working, unfortunately. That's too bad. But we could say basically similar to what we did before. I'm going to copy this maybe. Okay. So we produced 2 non-congruent triangles that have congruent. We're going to do angle, angle, angle here. Angle, angle, angle. Therefore, AAA is not a valid means for establishing triangle congruence. So they had all their angles matching. However, the triangles themselves are not congruent. Last one, determine whether side angle angle is a valid means for establishing triangle congruence. In this case, you know the measure of a side, an adjacent angle, and the angle opposite to that side. If it is a valid criterion, explain why. If it is not valid, use GeoGebra to create a counterexample demonstrating that it doesn't work and give an explanation. If you construct a counterexample, take a screenshot of your work, save it, and insert the image in the space below. Okay. So what we have is side angle angle. One of the things I want to point out is that this did not work. No. This did not work. No. Now we're going to try this one. Well, we already know angle side angle works, but do we know side angle angle if that works? Well, let's try an example. Okay. So I'm going to create 2 triangles. I'm going to use this triangle tool here. You might want to write this on a separate sheet of paper or something. Okay. So now let's say that this side is the side we're going to have the S. I want to say that it's maybe this length is 7, let's say. And this one matches because they have the same side, one side. And then we have angle, angle. Okay, so let's say this angle is, I don't know, 70 degrees. This one would have to be the same because we have side then angle. And let's say this one's the same as well, 50. So you can see that we have side, angle, angle, side, angle, angle. Okay. Now, if you recall, in any triangle, if you know 2 of the angles, you can figure out the third. Because in any triangle, the 3 angles always add up to 180. So because I know these 2 angles, that forces me to know this one as well. These 2 angles together add up to 120. But I know that the 3 angles in total should add up to 180. If you subtract that, you should be able to find the third angle. In this case, 60 degrees. Same idea, we can figure out this one. Well, now what? Well, now we can say that these two triangles are congruent. Here's the symbol for congruent, by the way. We could say these two triangles are congruent because angle side angle we already know works. And now we have angle side angle. Angle side angle. Okay. I hope that kind of makes sense, but that's what we're going to try to explain here. Okay. If we know two of the angles of a triangle, then we can figure out what the measure of the third angle is. Then we can use angle side angle to prove that the two triangles so side angle angle is a valid means for establishing triangle congruence. If I'm going too fast, you could always pause the video, rewind, watch it again. If it still doesn't make sense, you feel free to contact me. Okay. All right. Now, the next part we're going to go through. So on the next page, we're going to do some constructions. Okay. So we're in this first one, part A. It says, outline the process for inscribing an equilateral triangle in a circle. Perform the construction in GeoGebra. Take a screenshot of the construction, save it, and insert the image below. Okay. Again, if you can't insert the image, you could save the image and post it in later. Okay, so first thing I would need is a brand new sheet here. So I'm going to do new. I don't need to save this. Okay. Now, it says it wants us to produce an equilateral triangle inscribed in a circle. So the first thing I'm going to need is a circle. So go ahead and click on the circle tool. And we'll just create a circle using the first circle tool. All right. Now, here's one of the tricks we need to do. We need to produce a line that is a diameter across the middle of the circle. So we're going to produce a line. So not the segment, but the actual line tool. Go ahead and click on A, and then you can click out over here. Notice we've produced a diameter of the circle. Okay, I'm going to put a point right here as well. Okay. It'll make it easier to talk about. Now from there, we're going to actually create two more circles. So go back to the circle tool, click on that. First circle tool, circle with center through point. We're going to make another circle with center at point C. And then make it as big as that. Then we're going to create another circle, same idea, with center at point D, going to A. Okay, so we should have three circles kind of overlapping each other a little bit. And yeah, it should look something like this. Now, I want to put two more points. I want to put a point at this intersection and one at this intersection. Now, go back to the lines, go to segment. When you have the segment tool, connect E and F, connect E and D, and D with F. Do you see the equilateral triangle that we produced? Once you have that, take a screenshot of it and put it right here for part A. So what we produced was an equilateral triangle inscribed in a circle. Notice it's inside the circle and touching its corners. Okay, cool. So take a screenshot of that, put it here, and give me a brief explanation of what we did. So you could talk about how we created a circle, created a diameter for that circle, how we made 2 more circles on the edges of that diameter. Then we connected the points where those circles cross each other, where this circle and the main circle cross each other, and then the other point on the diameter to create an equilateral triangle. I'm not too concerned about the explanation. As long as you give it an honest effort, I'll be happy with that. Okay, so take a screenshot, put it right here, give me the explanation. That's about it. Okay, cool. Next one. Outline the process for inscribing a square in a circle. So we're going to start with the same idea, but instead of an equilateral triangle, we're going to produce a square. Okay, perform the construction in GeoGebra, take a screenshot, same idea. Except now, instead of a triangle, instead of an equilateral triangle, we want a square. Okay, so let me just go back a few steps. I still want the circle and I still want the diameter. Okay, so you should get back to this point. And you can just press undo and that'll get us back to here eventually. Now from here, I want to create a perpendicular line, a line that's perpendicular to this one. Now, if you recall, perpendicular means that they cross each other at 90 degrees. So we want a line that crosses this line at 90 degrees and goes through point A. So the way we do that is on the tools, you'll see this tool right here. It has a red line and a black line crossing each other. Go ahead and click on that. Go to the first tool, perpendicular line. Now we select the point A and we select the line CD, the diameter, and it'll produce another line. Notice these lines produce a perfectly right angle. Okay, they're called perpendicular to each other. Now we have enough that we can start producing our square. Go to the segment tool and produce the square. Do you see where the square is? It's kind of tilted. The square is going to be kind of tilted, like a diamond, some would say, but it's also still a square. Do you see where it'd go? See if you can pause the video and figure it out before I show you. Okay, so we're going to connect this point to this intersection here. If you don't see the square, if you haven't seen the square yet, maybe you see it now. Connect E to D, D to this intersection, and then here to there. And now we've produced a perfect square inscribed in the circle. Okay, take a screenshot of that, put it here, and give an explanation. So you might say that how we produce a diameter, then we produce another diameter perpendicular to the other, to the first, and connected the points where those diameters cross the circle and produced our square. Okay, great. Last question, part C. So we've produced a triangle inside a circle, equilateral triangle, and we produced a square inside a circle, inscribed. This one asks us outline the process for inscribing a regular hexagon in a circle. So if you recall, a hexagon means it has 6 sides. And since it's a regular hexagon, it's going to have 6 equal sides and 6 equal angles. Okay, so let's go back to where we were with our circle. Go ahead and click undo a few times until you get to this point right here. So again, we want the circle with the diameter going through. Okay, just like that. Now, this one's actually very similar to the one we did with the equilateral triangle. And I'll show you what I mean. So on our toolbar on top, go to the circle tool. Circle with center through point. And we're going to do the same thing we did for the equilateral triangle. So we're going to produce a circle with center at point C, and it goes to A. Similarly on the other side, same thing. Circle with center at point D, and it goes to A. Now go to your segment tool. Now, I want you to take a moment and see if you can spot where the regular hexagon would go. Okay, pause the video now. See if you can spot what things you need to connect in order to make the regular hexagon. Okay, I'll give you a moment to do that. All right, hopefully you've taken the time to try to figure that out. But we need to connect this point C to this intersection here. And this will be one of the sides of the regular hexagon. Connect this point to this intersection here, this point to this intersection, and then around. And there you go. We now have a regular hexagon inscribed in a circle. Go ahead and take a screenshot of that and briefly explain the process here. So we started by having a circle with the diameter. Then we produced 2 additional circles on the ends of that diameter. We connected the ends of those diameters to the points where these circles intersect each other. Where this circle intersects this circle, where this circle intersects this circle, and we produce the regular hexagon that way. So if you can give that explanation right here or a similar explanation, that would be perfect. Again, if you're having trouble, I think that's the last one. Yeah. Okay, great. Okay, so that was that. Again, if you're still having trouble, feel free to contact me. I know this is kind of a long and difficult one, but you always have access to getting help from me directly. And my email address, once again, is ttrigg@ofy.org. All right. All right. I hope that all made sense. Feel free to email me with any questions or if you need additional help. And I will be recording the Unit 4 activity hopefully today. All right. Well, farewell. Stop recording.